Okay, here's the third video for moon phases. This is pretty much all you need to know about moon phases for the STAR test in 8.7b, which calls for you to be able to demonstrate and predict the sequence of events in the lunar cycle. So you're going to start with like a blank canvas or a blank piece of paper, and you're going to add in the sun and the earth. Obviously, this is not to scale. The moon phases depend on the relationship between the sun, the earth, and the moon. So I'm going to go ahead and add the moon at 4 different positions first. So just go across and up and down, and then fill in the gaps in between with another set, and that's going to give you all 8 moon phases. This is probably a more accurate view of the scale of the earth versus the moon size and the distance. So as you can see, if we try to do this on one picture, this would be very difficult. So that's why we've kind of shrunken everything down just to be able to see it. Alright, we're going to start with the new moon. It's always on the sunny side. So no matter where the sun is in the model, you know on that sunny side, that's where the new moon is. And then opposite of that, or on the other side, is going to be the full every single time. So when looking at a model like this, new's on one side, full's on the opposite side. Alright, next thing you need to know is that going in order counterclockwise, because a misconception could be to go the wrong way. If you go clockwise, you're going to end up having some problems with your model and with your ability to predict the locations of the moon during certain phases. Just remember, everything after new is waxing, and the light starts to show up on the right side, and that after full, the light starts to disappear toward the left. Next set that's really easy to remember is the quarter and the three-quarter moons. They just look like a half moon, right? But so for the first quarter, just remember that the light is on the right because it's after the new. So just make sure when you draw that, you make sure and leave the light on the right and shade in the left. And then here, the light's on the left, and then you're going to want to shade in the right for that three-quarter moon. In between the gibbous moons is the full moon. So that's a really easy way to fill that in, is just put the gibbous moons right there, and we know they're gibbous because they're big, right? And we know this one is the waxing because it's after the new moon. And we know that this one is the waning gibbous because it's after the full moon. Alright, and then the crescents have a light that looks like AC, and the crescent moon here is waxing because it's after new, so it's a waxing crescent. And then this one's a waning crescent because it's after full. Or if you remember the Batman illustration, Batman's waxing the streets here. When he gets to new, he's now waning, right? Okay, next thing you need to know is the percentages of light on each face. So there's 0% light visible from Earth at a new moon, but 100% at a full. So when there's a full moon, we can see 100% of the light. And then the next easiest ones to remember are your first quarter and your third quarter moons, because they are at 50%. And then the next ones are just going to be in between. For crescent moons, you have between 1 and 49%. Same thing here, between 49 and 1%. The gibbuses are between 51 and 99%. I know it's a lot of numbers, but if you just think about it like this, between 0 and 50, as long as it's between 0 and 50%, it's going to be a crescent moon. If it's between 50 and 100, it's going to be a gibbous moon. The last thing you need to know is that each phase takes 3.5 days approximately to calculate and move phases. So like, let's say if I was at the new moon and I wanted to know when the next gibbous phase would be, well, let's see how many days that would be. So let's count our phases from here. We go 1, 2, and 3. So that's 3 phases, right? Times 3.5. So 3.5 times 3, 10.5 days. And we could round that up to 11 days and be just fine. So we'd know that from this new moon, the next gibbous would be in about 11 days. So you have to also do this the other way. You should be able to fill in the same model no matter where the sun is. So again, I'm just going to draw 4 moons across and then fill in the gaps to make a total of 8. And then what's always on the sunny side? You got it. The new is always on the sunny side. And therefore, what's on the opposite side? The full. We're going to remember that we're going to go counterclockwise. Remember, the opposite way that a clock runs is the way that it's going to revolve. Afternoon is going to be all your waxing phases. All right. After full is going to be all your waning phases. First quarter moon, these two are really easy because they're the ones that look like half moons. We actually call them quarter moons. So after the new is the first quarter, after the full is the third quarter. Next we can fill in the gibbous. The full is between them. And remember, gibbous looks like big light, but not full. That crescents look like a C. They're light. The light on the moon looks like a C, so you know it's a crescent. We know that this side is again waxing crescent, waxing gibbous because it's after the new. This side is waning gibbous and waning crescent because it's after the full. The new moon has 0% of its light showing. The full moon has 100% of its light showing. The quarter moons both have 50% of their light showing, and everything else is in between those numbers. So gibbous and crescent are in between those numbers. So for example, again, between 1 and 49% is the crescent on both sides, and between 99 and 51% is the gibbous. Also, don't forget 3.5 days for each phase, and 3.5 days times the phases gives you the days to the phase asked for. So let's say we're starting with a crescent, and they said, when's the next 3/4 moon? Okay, so then from here we're just going to count 1, 2, 3, 4, 5 phases. 5 times 3.5 is 17.5. So 17.5 days until from the crescent moon until the third quarter moon. So that's how you can use that calculation to make predictions. Again, don't forget that it doesn't matter which side the sun's on, because you know where your starting place is going to be. On that sunny side, that's where your new moon's going to be. Opposite is full. In between new and full is the quarters, and so on. So it's the same process you can use every time to find, to enter into that work and find the answer that you need. Again, one thing that they like to do is give you some type of model and then ask you where the sun should be. And so that's kind of the backwards of what I just showed you. So, but it's easy, right? Because we know that the new moon is always on the sunny side. Boom, there's the sun. That's where it should be. And you'll also sometimes see this little set of moon phases, but this is from the outside perspective. So this is from like third person looking at the Earth, Sun, and Moon from outer space. What is typically going to be asked of you, though, is to give the phases from the point of view of Earth, and that's what I've shown you how to do. I hope this has been helpful. Have a great day.